Hello, and welcome to the lesson on Pythagoras Theorem. The three things that we are going to learn in this lesson are: first, we'll understand what is Pythagoras Theorem. Then we'll go on to find out what are Pythagorean Triads. And finally, we'll see how can we use Pythagoras Theorem and Pythagorean Triads to identify whether a triangle is right angle triangle or not. Let's begin then. It is really fascinating that in ancient times, people were building such beautiful structures even without having proper geometric equipments or even the construction equipments. How do you think they would measure different dimensions of the construction? Well, the Greeks, the Egyptians used to measure the height and the width of the pyramid using ropes or threads which had knots in them. And they used to have some lengths designated, and that's how they used to measure different dimensions of the pyramids. Well, they realized that while building pyramids, they had to have a perfectly right angle, okay, a 90 degrees angle. Now, they didn't have protractor there back then, so they derived a specific relationship between the three sides in a right angle triangle. This was later discovered by the Greek philosopher Pythagoras. But then this was originally done by Egyptians. Egyptians used to use these ropes, okay, and construct right angle triangles. And that's how they used to measure the 90 degrees angle. Fascinating, isn't it? So that's what is the history of Pythagoras theorem. To understand what is Pythagoras theorem, we need to understand some terminologies regarding right angle triangle. One of them is hypotenuse. Now, what is hypotenuse? In a right angle triangle, the longest side is the side opposite to right angle, and that is what is called the hypotenuse. For example, in these two right angle triangles, can you identify which side is the hypotenuse? For that, let us first identify which is the 90 degrees angle. Well, in the first case, the side opposite to 90 degrees angle is that one. So that's the hypotenuse. In the second figure, the 90 degrees angle, as you can see, it's indicated by a little square at the corner. The side opposite to that is this one. So that's the hypotenuse. So irrespective of the orientation in which the right angle triangle would be in, you should be in a position to identify hypotenuse for that triangle. Right. Now let us try and identify or investigate what could be the lengths of sides in a right angle triangle. So let's first draw a triangle with a base of 4 centimeters. Let's make the height of that triangle 3 centimeters. Now, what do you think will be the hypotenuse, right? Let's measure that. We'll first join it and then measure it. As you can see, the length of the hypotenuse is 5 centimeters, right? Let's leave it there. Let's draw one more right angle triangle. This time, we'll make the base length 12 centimeters, as you can see, and let the height be 5 centimeters. What do you think the hypotenuse is going to be? Let's first construct the hypotenuse and then measure it. As you can see, in this case, the hypotenuse is 13 centimeters. Finally, let's draw one last triangle. This time, the base is going to be 15 centimeters and height is going to be 8 centimeters, as you can see. And what do you think is the hypotenuse in this case? Join it and measure it. As you can see, the hypotenuse is 17 centimeters. Now, do you remember the three triangles that we drew, the dimensions? Well, here they are. We first drew a triangle with base 4, height 3, the hypotenuse is 5. Then we drew the triangle with base 12, height 5, the hypotenuse we measured was 13 centimeters. And finally, we drew a triangle with a base 15 and height 8 centimeters, and the hypotenuse was 17. Correct? Now, what is the relationship between the three sides in a right angle triangle? Let's identify that. So in the first case, the side 1, side 2, and hypotenuse were 3, 4, and 5 respectively. Now if I square each of these numbers, 3 squared is 9, 4 squared is 16, and 5 squared is 25. In the second case, the sides were 5, 12, and 13. Likewise, I'll square all of them. 5 squared 25, 12 squared is 144, and 13 squared is 169. In the third triangle, the sides are 8, 15, and 17. The respective squares are 64, 225, and 289. Now look at the squares carefully and try to find out how do you think are the three values related to each other. Well, you don't have to think too much, okay? It's first plus second gives you third. 9 plus 16 is 25. In the second case again, 25 plus 144 is 169. In the third case, 64 plus 225 is 289. Interesting, isn't it? Now, that brings us to the Pythagoras theorem, which I said was deduced by the famous Greek philosopher and mathematician Pythagoras. He was instrumentally in deriving the relationship between the lengths of the sides in a right angle triangle. That's exactly what we derived a while back. In a right angle triangle, these are the perpendicular sides, and that's the hypotenuse. So, what Pythagoras derived was interesting. He said the sum of the squares of the perpendicular sides is equal to the square of the hypotenuse. For example, if I label the sides as A, B, and C, where C is the hypotenuse, A and B are the perpendicular sides, then what Pythagoras said is sum of the squares of the perpendicular sides. So if I square the perpendicular sides, I'll get A squared and B squared. And sum means addition, correct? A squared plus B squared. And he said that is equal to the square of the hypotenuse, which is C squared, right? And this is exactly what we had derived a while back. Remember? Remember this triangle that we had 3, 4, and 5, and we had derived that 3 squared plus 4 squared, which is 9 plus 16, is 25, and 25 is nothing but 5 squared, right? So it's the same thing, right? 3 squared plus 4 squared is 5 squared. So if I square the two perpendicular sides and add them, I will end up getting the square of the hypotenuse in a right angle triangle. Okay, that means that if I were to construct a square of on the each of the perpendicular sides, so the square on the side with length 3 will have an area of 9 square units. Likewise, the square on the side which is 4 centimeters will have an area of 16 square units. So what Pythagoras is trying to tell us is the addition of the areas of these two squares, which is 9 plus 16 is 25, will be the same as the square area of the square which is constructed on the hypotenuse. Right? On the hypotenuse, the square which is constructed will have an area of 25, and hence the length will be 5. So that's very interesting, right? It's the same thing as saying 3 squared, which is area of the first square, plus 4 squared, which is area of the second square, equals 5 squared, which is area of the third square, the one which is constructed on the hypotenuse. Right? 3 squared plus 4 squared equals to 5 squared. Likewise, we can derive a similar relationship for all the other triangles that we had derived. If you remember, we had 5 squared plus 12 squared equals to 13 squared. Remember, the second triangle was base of 5, base of 12, height of 5, the hypotenuse was 13. Correct? And likewise, 7 squared plus 24 squared is 625, which is 25 squared. So the hypotenuse will be 25 in this case. Now, that brings us to this concept of Pythagorean triads. Now, what are Pythagorean triads? Basically, the lengths of the sides that form a right angle triangle are called Pythagorean triads. It's as simple as that, which means 3, 4, and 5, which is going back to the same triangle again. The height is 3, base is 4, and the hypotenuse is 5. Okay, that forms a right angle triangle, and hence 3, 4, 5 is a Pythagorean triad. So the lengths of the sides which form a right angle triangle is nothing but Pythagorean triad, because it's a triad because there are three values, right? In a right angle triangle, there are three sides. So there will be three values, and the lengths of the right angle triangle are basically the right angle triad, the Pythagorean triad, right? So what is the triad which completes 5 and 12? Now we drew this triangle, remember? So we had said 5 squared plus 12 squared, which is 25 plus 144 is 169. And 169 is 13 squared, right? So the Pythagorean triad which completes this is 5, 12, and 13. Now, there's an interesting way in which you can go about finding various triads. Okay, now this is something which you'll not find in many textbooks. So listen to this carefully. There are three different cases. Okay, the first case is where the smallest side is odd. Now this is the easiest of the cases. The first step is to square the smallest side. So if the smallest side was 3, for example, that's an odd number. So you square the smallest side, which is 9. 3 squared is 9. And then you split this result into two consecutive numbers. So how can you split 9 into two consecutive numbers? Well, it's 4 and 5, right? And there you go. That's a triad. 3, 4, and 5 is a triad. Remember? Okay, let's do one more. What if the smallest side was 5? Okay, as per the step, you square that. 5 squared is 25. And then you split this square into two consecutive numbers. So 25 can be split as 12 and 13. So 5, 12, and 13 is another triad. Remember, these are the triads that we had already derived. But now we are looking at a method wherein we can derive just about any triad, right? You just pick any odd number, square it, split it into two consecutive numbers, and there you go. You get a triad, right? What if the smallest side was even? Okay, let's see. So let's begin with smallest side being 6. So in this case, again, the first step is the same. So you square the smallest side. So 6 squared is 36. The only additional step in this is you divide this by 4. So you divide the square by 4. So 36 divided by 4 is 9. And the third step is you take the previous number to 9 and the next number to 9. So the previous number is 8 and the next number is 10. So 6, 8, and 10 will form a triad. If you don't believe me, 6 squared is 36, 8 squared is 64, 36 and 64 is 100, which is 10 squared. So look, it satisfies that. 6 squared plus 8 squared is 10 squared. Let's take one more example. What if the smallest side was 8, right? So let's do that. 8 squared is 64. Because 8 is an even number, we need to have that additional second step. Divide the result by 4. So 64 divided by 4 is 16. Then you take the previous number to 16 and the next number to 16. So we have 15 and 17. So 8, 15, 17, which is a triad which we are familiar with, right? 8, 15, 17 is something which we drew. Remember, 8 squared plus 15 squared is 17 squared. So this is how you can find triads for just about any side which is the smallest side, odd or even. You know the two different rules of deriving triads. But the most powerful rule is the third rule. And this is what I love. Common multiple of any triad gives you another triad. Okay, you can take just any triad like a 3, 4, 5 and multiply all three numbers by a small multiple like 2, right? What if I double all the three sides? You'll get 6, 8, 10, and yours. That's another triad. 6 squared plus 8 squared is 10 squared, right? You could have multiplied the original values by just about any number. For example, what if I make it 5 times? So 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. And that's a triad. 15 squared is 225, 20 squared is 400, 225 plus 400 is 625, which is 25 squared, right? So you just take any basic triad and take any multiple of that triad, okay? Multiply all the numbers by a common number, and you get another triad. Isn't that interesting? Now we'll use this rule to figure out which of these triangles forms a right angle triangle. Okay, so you can use any of the basic triads that we learned, either 3, 4, 5 or 5, 12, 13, and try to find out without using a calculator whether this is a right angle triangle or not. Remember, if it is a right angle triangle, then it should follow the Pythagoras theorem or it should follow follow the Pythagorean triad. So the first number, 3, 4, 5, first triad, if you look at the first triangle, it has a 3, it has a 4, but the hypotenuse is 6, which means clearly that cannot form a right angle triangle. Because if it was indeed a right angle triangle, then the hypotenuse should have been 5. Okay, if you look at the triad carefully, it's 3, 4, 5. Now, look at the second triangle now. Does it ring a bell? Which triad will you use? I'll use the second triad, 5, 12, and 13, and I'll try and double the numbers. If I double 5, I'll get 10. If I double 12, I'll get 24. If I double 13, I'll get 26. Perfect match, right? 10, 24, 26, which means that is a right angle triangle. How about the third one? Third triangle. Go back to the first triad, okay, and make it 3 times. If I make all the numbers 3 times, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. It's a perfect match, which means even that triangle is a right angle triangle because it follows the rule of triad. If you multiply the triad by a common number, you should get another triad, right? What about the fourth triangle now? Okay, let's stick to the first triad, that is 3, 4, 5. And this time I'll multiply each of these values by 5. What will you get? 3 times 5 is 15, 4 times 5 is 20, and 5 times 5 is 25. Perfect match. So it is a right angle triangle. Let's go to the fifth triangle. And this time, let me pick the second triad, 5, 12, and 13. What if I make each of these numbers 3 times? 5 times 3 is 15, 12 times 3 is 36, and 13 times 3 is 39. We have 15 and 39, but we don't have 36, so that's not a right angle triangle. Instead of 25 as the base, we should have had 36 as the base. Then that would have been a triad, or a right angle triangle, I would say. The last one, sixth one, look at the first triad, and maybe I'll multiply that by 10. Okay, if I multiply that by 10, I'll get 30, 40, and 50. Now we have 40 and 50, but we don't have 30, which means that's not a right angle triangle. Well, that's the end of this lesson on Pythagoras theorem. I hope you understood the concepts here. We first understood what is Pythagoras theorem. Then we did some investigation on right angle triangles. We drew a lot of right angle triangles, and then we derived the Pythagoras theorem. Then we went on to an interesting concept called Pythagorean triads and how to derive different triads. And then we use those Pythagorean triads to identify whether a triangle is a right angle triangle or not. Well, I hope you enjoyed this lesson. Thank you.